Hi class, in this quick video we're going to talk about angles of rotation based on a coordinate plane and how it works with trigonometry. Let's start off with just positive rotation, and what that means is I'm just going to start off with that blue arrow, this arrow right here that you see that's blue, and I'm just going to rotate it about this origin here 135 degrees. Positive rotation will always go from quadrant 1 to quadrant 2 to quadrant 3 and then to quadrant 4. And the cool thing is that if I was doing, say, a positive rotation of 600 degrees, that means that I would do 365 plus another 300, so then I would end up being right about there. It's just exactly like the hands of a clock, only time is spinning backwards. Alright, now from here you can also deal with negative rotation, and the only difference is that the indicator says, well, we're interested in rotation of negative 45 degrees as opposed to positive 45 degrees. And whenever you see that negative sign right there, that just means that it's going to be exactly like the arms of a clock, and everything is going to rotate in the negative direction. So it's all going to head in this way. Okay, from here, a couple terms that we probably need to talk about. One of them is coterminal angles. And coterminal angles are, well, they're pretty easy to get. And the way that I think of this is back in the day when you were in geometry, you were talking about supplemental. And supplemental, well, that is just 180 degrees. If you add angle 1, so measure of angle A plus measure of angle B equals 180, well, we knew that the two of them together gave me 180 degrees. Coterminal angles is exactly the same, only it's looking at it from a slightly different direction. Either way, though, the sum of the two angles is going to have to equal 360. So I could take 120, and then, even though this is a negative sign right here, because that's just telling me to rotate around in the other direction, I'm going to do 240 here, and if I add things up, I should get 360 degrees, and I do. Great. Okay, the next thing up that we want to talk about is a reference angle. And a reference angle is similar to a coterminal angle, only the reference angle is just the remaining area, that's that pink area right there, from theta, and it's always based off of 180 degrees minus theta, and that equals your reference angle. Okay, next up is talking about how this applies with trig. Okay, so all these angles of rotation and, well, what does that have to do with trig? Well, it all goes back to the Pythagorean theorem and making triangles. For instance, let's say I start off with just a regular old nice looking triangle that goes from, about here, makes a point right there, and then we could bring it down and then back over. Okay, and obviously this is, high-tech scribbly stuff right here. If we want to know what this angle is, and let's call that angle theta, we can use some trigonometry to figure it out. Now let's say that this point right here is 3, 4. Okay, so that means that I go over 3 in this direction and 4 in this direction, and we could probably use 3 squared plus 4 squared equals c squared to figure out what r is. And the reason I call this r is because if I was to make a circle, that's the radius that can spin around as theta changes. Okay, so let's get rid of r there for a second. Let's solve for c squared. So that means we've got, whoops, lots of circles here still. Okay, so that means we've got 9, and then we're going to add 9 with 16, and that equals 25. So r, or c, whichever one you want to look at, whichever way you want to look at it, equals 5. Great. So now we know that instead of r, I'm going to get rid of that, and I'm just going to say 5. Cool. From here, I'm going to find sine, cosine, and tangent of this theta in here. All right, so we got so, ca, toa, and when we're finding the sine of theta, we're doing the opposite over hypotenuse. So sine theta equals 4 over 5. And then cosine is going to be, let's erase these reds here. I don't need that one. but it is going to be adjacent over 5, so, or adjacent over hypotenuse, so cosine of theta equals 3 over 5. And then lastly, tangent of theta equals opposite over adjacent. So that's going to be, erase those there, that's going to be 4 over 3. So there's my 4/3. And then one little curveball to throw in there, if we were talking about what's called cosecant, secant, and cotangent, so that's cosecant, then secant, and tangent, these are, and cotangent, whoops, these are all reciprocals of sine, cosine, and tangent. So the cosecant is 1 over sine theta, which equals 5 over 4. Secant is 1 over cosine theta, which equals 5 over 3. And cotangent is 1 over tangent theta, which is 3 over 4. This is the beginning of figuring out the unit circle.